Declassified video of the test of the Soviet Tsar Bomb, a powerful weapon, after which ground tests were partially banned. AN 602, also known as Tsar Bomba, as well as, erroneously, RDS 202 and RN 202, is a thermonuclear aerial bomb developed in the USSR in 1956–1961. A group of nuclear physicists led by Academician of the USSR Academy of Sciences I.V. Kurchatov tested back in 1961, the so-called RDS 220, which was also called the Tsar Bomba, had a capacity of approximately 50 million tons of TNT. I want to tell you about this unique event and the declassified video today. The AN 602 tests took place on October 30, 1961 by dropping from a 295 volts aircraft at the Dry Nose Nuclear Test Site, Novaya Zemlya Island. The measured power of the explosion was 58.6 megatons of TNT, or about 2.4 by 1017 J, corresponding to a mass defect of 2.65 kilograms. The AN 602 tests clearly demonstrated the Soviet Union's possession of an unlimited power weapon of mass destruction. The scientific result was an experimental verification of the principles of calculation and design of thermonuclear charges of a multistage type. AN 602 was a modification of the RN 202 project. In the mid-1950s, the United States had superiority over the USSR in nuclear weapons, although thermonuclear charges had already been created in the USSR by that time. They did not have the necessary diversity. Also in the 1950s, there were no effective means of delivering nuclear weapons to the United States. The USSR did not have a real possibility of a retaliatory nuclear strike on the United States. Official names: Product 602 inches, AN 602. Ivan. Currently, the difference in names becomes a cause of confusion when AH602 is mistakenly identified with RDS-37 or with RN-202. Product 202. AN602 was a modification of the PH202. Correspondence for the PH202 originally used the designation RDS-202, 202 and Product B. The development of this super-powerful bomb began in 1956, and was carried out in two stages. At the first stage, from 1956 to 1958, it was the Product 202 inches, which was developed in the NI 1011 created shortly before. The current name of NI 1011 is Russian Federal Nuclear Center, All-Russian Research Institute of Technical Physics, RFNCV. According to the official history of the institute, the order to establish a research institute within the system of the Ministry of Medium Machine Building of the USSR was signed on April 5, 1955. Work at NI 1011 began a little later. At the second stage of development, from 1960 to a successful test in 1961, the bomb was called Product 602 and was developed at KB11, now Vnayev, V.B. D. Sakharov, U.N. Babev, U.N. Smirnov, U.A. Trutnev. Product 202, RDS 202. After the successful testing of the RDS-37, the employees of KB11, Sakharov, Zeldovich and Davydenko, performed a preliminary calculation and on February 2, 1956 handed over to N.I. Pavlov a note with an estimate of the parameters of the charges of 150 Mount and the possibility of increasing the power to 1 gigaton FC. After the creation in 1955 of the second nuclear center, NI 1011, in 1956, by a decree of the Council of Ministers, it was given the task of developing a super high power charge, which was called Project 202 inches. On March 12, 1956, a draft joint decree of the Central Committee of the CPSU and the Council of Ministers of the USSR on the preparation and testing of Product 202 was adopted. The project planned to develop a charge based on the principle of the RDS-37 product with a capacity of 30 Mount FC. RDS-202 was designed with maximum calculated energy release 50 megatons, with a diameter of 2.1 meters, a length of 8 meters, a weight of 26 tons with a parachute system and structurally coordinated with a Tu-95-202 carrier aircraft specially converted for its use. On June 6, 1956, the NE 1011 report described the RDS-202 thermonuclear device with an estimated power of up to 38 mount with the required task of 20-30 mount. In reality, this device was developed with an estimated power of 15 mount. After testing the product's 40 giganewtons, 245 and 205, its tests were found to be inappropriate and cancelled for various reasons. RDS-202 was assembled on the principle of radiation implosion, tested earlier when creating RDS-37, since it used a much heavier secondary module than the RDS-37, not one, but two primary modules. Charges, located on two opposite sides of the secondary module, were used to compress it. This physical charge scheme was later used in the design of the AN-602, but the AN-602 thermonuclear charge itself, secondary module, was new. The RDS-202 thermonuclear charge was manufactured in 1956, planned for testing in 1957, but was not tested in 1957. And was put into storage the same year. 2 years after the manufacture of the RDS-202, in July 1958, it was decided to remove it from storage, dismantle and use automation units and charge parts for experimental work. Order by the Ministry of Medium Machine Building of May 23, 1957, number 277, item 602 in 1960, KB11, now VNIEF. Began developing a thermonuclear charge with a design capacity of 100 mount. In February 1961, the leaders of KB-11 sent a letter to the Central Committee of the CPSU some questions of the development of nuclear weapons and methods of their use, which, among other things, raised the question of the advisability of developing a charge with a capacity of 100 mount. On July 10, 1961, a discussion took place in the Central Committee of the CPSU, at which Khrushchev supported the development and testing of a super-powerful bomb. To speed up work on the AN-602, the developments of the 202 project were used. While the AN-602 was not a renamed RN-202, it was a new project and it was developed by another group. The A602 charge was an analog of the R202 charge with the introduction of some modern, for that time, technical solutions into it. The surviving technologies were used. The Tu-95-202 carrier aircraft developed for the 202 product, and the concept of ensuring the safety of the carrier aircraft during the explosion of a thermonuclear superbomb. In particular, in KB-11, VNIEF, 6 cases for the Project 202 bomb already manufactured at NE 1011, VNIEF, were taken and a set of equipment developed for its testing was used. Also, in its manufacture, several bags of documentation exported from VNIEF to KB-11 were used for the development and planning of tests of Product 202. AN-602 had a 3-stage design. The first stage was not one, but 2 thermonuclear initiator charges placed in the front and rear of the bomb. The total estimated contribution of the first stage to the explosion power is 1.5 megatons, which were used for radiation implosion, compression, of the second main thermonuclear stage. Radiation implosion launched a thermonuclear reaction in the second stage. The contribution to the explosion power is 50 megatons. In the 3-stage design, the second, fusion, stage, in turn, could initiate a nuclear Jekyll-Hyde reaction, fission of uranium-238 nuclei by the action of fast neutrons produced as a result of a fusion reaction, which could add another 50 megatons of power, so that the total design capacity of AN-602 was 101.5 megatons. Testing of a full, 3-stage, 100-mount version of the bomb was rejected due to the extremely high levels of radioactive contamination that would have been caused by a fission reaction of a large amount of uranium in the 3rd stage. During the test, the bomb was used in a 2-stage version. A.D. Sakharov suggested using the nuclear passive material lead instead of U-238 in the secondary bomb module, which reduced the bomb power to 50 mount tech, and, in addition to reducing the number of radioactive fission fragments, made it possible to avoid touching the fireball of the Earth's surface. This excluded radioactive contamination of the soil and raising large amounts of radioactive dust into the atmosphere. Many technical innovations were applied in the design of the AN-602. The thermonuclear charge was made according to the Bofiller scheme. Radiation implosion of the main thermonuclear unit was carried out from two opposite sides. To do this, two initiator thermonuclear charges were placed in the front and rear parts of the bomb, for which a synchronous, with a difference of no more than 0.1 seconds, detonation was provided. These charges produced X-ray compression of the main thermonuclear charge. To ensure synchronous detonation of charges with the required accuracy, the serial detonation automation unit was finalized in KB-25, Nalvnia. Development of a carrier aircraft. Main article, Tu-95. To deliver the bomb, a team led by Alexander Nadashkevich in 1955 developed a modified version of the Tu-95 bomber, Tu-95 volts. Another name, Tu-95-202. This aircraft was made in a single copy. The first studies on this topic began immediately after I.V. Kurchatov's negotiations in the autumn of 1954 with A.N. Tupolev, who appointed his deputy for weapons systems A.V. Nadashkevich as the head of the topic. The analysis showed that the suspension of such a large bomb would require major changes in the aircraft. In the first half of 1955, the dimensions, weight and placement of the AN-202 in the aircraft were agreed upon. As expected, the mass of the bomb was 15% of the takeoff mass of the carrier, but due to its size, the aircraft was left without external fuel tanks. A new beam holder based on BD-206 was developed for the AN-202 suspension. The developed new BD-795-242, BD-242, was much more carrying capacity than BD-206. It had 3 Dair 5.6 bomber locks with a carrying capacity of 9 tons each. 3 locks created the problem of safely dropping the bomb, and it was solved. The electric automatics ensured the synchronous opening of all 3 locks. On March 17, 1956, the decree of the Council of Ministers of the USSR No. 357-228 SS was issued, according to which OKB 156 was to begin converting the Tu-95 into a carrier of high-power nuclear bombs. These works were carried out at the Limap, Zhukovsky, from May to September 1956. Then the Tu-95 volts was accepted by the customer and handed over for flight tests, which were conducted, including dropping the super bomb mock-up, under the leadership of Colonel S.M. Kulikov until 1959 and passed without any special remarks. The carrier of the super bomb was created, but its real tests were postponed for political reasons. Khrushchev was going to the USA, and there was a pause in the Cold War. The Tu-95 volts was transferred to the airfield in Uzin, where it was used as a training aircraft and was no longer listed as a combat vehicle. In 1961, with the decision to test, the Tu-95 volts was urgently replaced with all the connectors in the electric reset system and the bomb bay doors were removed. A real bomb in terms of mass, 26.5 tons, including the weight of the parachute system, 0.8 tons. And the dimensions turned out to be somewhat larger than the layout. In particular, now its vertical dimension exceeded the dimensions of the bomb bay in height. The aircraft was also covered with a special white reflective paint. In the fall of 1961, the aircraft was modified for testing AN-602 at the Kuibyshev aviation plant. The bomb tests took place on October 30, 1961 at the State Test Site No. 6 of the USSR Ministry of Defense, located on Novaya Zemlya. Khrushchev personally announced the upcoming tests of a 50 megaton bomb in his report on October 17, 1961 at the 22 Congress of the CPSU. Before the official announcement, in an informal conversation, he told one of the American politicians about the bomb, and this information was published on September 8, 1961 by the New York Times. October 30, 1961 Tu-95 volts number 5,800,302 with a bomb on board took off from the Olenia airfield. The first studies on this topic began immediately after I.V. Kurchatov's negotiations in the autumn of 1954 with A.N. Tupolev, who appointed his deputy for weapons systems A.V. Nadashkevich as the head of the topic. The analysis showed that the suspension of such a large bomb would require major changes in the aircraft. In the first half of 1955, the dimensions, weight and placement of the AN-202 in the aircraft were agreed upon. As expected, the mass of the bomb was 15% of the takeoff mass of the carrier, but due to its size, the aircraft was left without external fuel tanks. A new beam holder based on BD-206 was developed for the AN-202 suspension. The developed new BD-795-242, BD-242, was much more carrying capacity than BD-206. It had 3 Dair 5.6 bomber locks with a carrying capacity of 9 tons each. 3 locks created the problem of safely dropping the bomb, and it was solved. Electric automatics ensured the synchronous opening of all 3 locks. On March 17, 1956, the decree of the Council of Ministers of the USSR No. 357-228 SS was issued, according to which OKB 156 was to begin converting the Tu-95 into a carrier of high-power nuclear bombs. These works were carried out at the Limep, Zhukovsky, from May to September 1956. Then the Tu-95 volts was accepted by the customer and handed over for flight tests, which were conducted, including dropping the super bomb mock-up, under the leadership of Colonel S.M. Kulikov until 1959 and passed without any special remarks. The carrier of the super bomb was created, but its real tests were postponed for political reasons. Khrushchev was going to the USA, and there was a pause in the Cold War. The Tu-95 volts was transferred to the airfield in Uzin, where it was used as a training aircraft and was no longer listed as a combat vehicle. In 1961, with the decision to test, the Tu-95 volts was urgently replaced with all the connectors in the electric reset system and the bomb bay doors were removed. A real bomb in terms of mass, 26.5 tons, including the weight of the parachute system, 0.8 tons, and dimensions turned out to be somewhat larger than the layout. In particular, now its vertical dimension exceeded the dimensions of the bomb bay in height. The aircraft was also covered with a special white reflective paint. In the fall of 1961, the aircraft was modified for testing AN-602 at the Kuibyshev aviation plant. Tests. The bomb tests took place on October 30, 1961 at the State Test Site No. 6 of the USSR Ministry of Defense, located on Novaya Zemlya. Khrushchev personally announced the upcoming tests of a 50 megaton bomb in his report on October 17, 1961 at the 22 Congress of the CPSU. Before the official announcement, in an informal conversation, he told one of the American politicians about the bomb, and this information was published on September 8, 1961 by the New York Times. October 30, 1961 Tu-95 volts number 5,800,302 with a bomb on board took off from the Olenya airfield. 2 hours 3 minutes after takeoff at an altitude of 11.5 kilometers above the target level, the bomb was dropped from the carrier aircraft, after which it descended on the main parachute with an area of 1,600 square meters. The total mass of the parachute system, which included 5 more pilot chutes, triggered by 3 cascades, was 800 kilograms. The bomb was detonated by a barometric fuse 189 seconds after being dropped at 11:33 UTC, 8:33 UTC, at an altitude of 4,200 meters above sea level, 4,000 meters above the target. Other sources give different heights of the explosion, from 3,700 meters above the target, 3,900 meters above sea level, to 4,500 meters. The carrier aircraft at the time of the explosion was at a distance of about 39 kilometers, and the laboratory aircraft minus 53.5 kilometers. The shockwave caught up with the carrier aircraft at a distance of 115 kilometers. The effect of the shockwave from the explosion was felt in the form of vibration and did not affect the flight mode of the aircraft. After landing, Several spots from the impact of the explosion flash were seen on the fuselage. The aircraft laboratory at the time of the arrival of the shockwave was at a distance of 205 kilometers from the explosion site. Test results size comparison of fireballs of nuclear explosions. The radius of the zone of continuous destruction during the explosion, superimposed on the map of Paris for clarity. The explosion of AN 602 according to the classification of nuclear explosions was a low-air nuclear explosion of extra high power. His results were impressive. The flash was visible at a distance of more than 1,000 kilometers. It was observed in Norway, Greenland and Alaska. The nuclear mushroom of the explosion rose to a height of 67 kilometers. The shape of the hat is two-tiered. The diameter of the upper tier is estimated at 95 kilometers, the lower one is 70. The cloud was observed 800 kilometers from the place of the explosion. The blast wave circled the globe 3 times. The first time in 36 hours and 27 minutes, a seismic wave in the Earth's crust, generated by the shock wave of the explosion, circled the globe 3 times. The atmospheric pressure wave resulting from the explosion was recorded 3 times in New Zealand. A station in Wellington, New Zealand, registered an increase in pressure at 21:57 on October 30. The arrival of a wave from the northwest, at 7:17 on October 31, from the southeast, and at 9:16 on November 1, from the northwest, GMT time, with an amplitude of 0.6, 0.4 and 0.2 millibars, respectively. The average wave speed is estimated at 303 meters per second, or 9.9 degrees of great circle arc per hour, 780 kilometers from the explosion in the village on about. Dixon shattered glass in the windows. The sound wave generated by the explosion reached Dixon Island at a distance of about 800 kilometers, but there are no reports of destruction or damage to structures even in the urban-type settlement of Andermill located much closer, 280 kilometers, to the landfill. Atmospheric ionization caused radio communication interference even hundreds of kilometers from the test site for about 40 minutes. Radioactive contamination of the experimental field with a radius of 2 to 3 kilometers in the epicenter region was no more than 1 milliroentgen-hour. The testers appeared at the explosion site after 2 hours. The radioactive contamination posed practically no danger to the test participants. Consequences of the test. The creation and testing of the superbomb were of great political importance. The Soviet Union demonstrated its potential in creating a nuclear arsenal of unlimited power. At that time, the most powerful thermonuclear charge tested by the United States was 15 Mount. It is curious that the United States did not increase the power of thermonuclear tests after the AN 602 test by the Soviet Union, and in 1963 the Treaty on the Prohibition of Nuclear Weapons Tests in the Atmosphere, Outer Space and Underwater was signed in Moscow. The Soviet AN 602 thermonuclear aerial bomb, the so-called Tsar Bomba, was useless in strikes against the United States in the 1960s. This was written by the American magazine The National Interest. According to the newspaper, the bomb was too heavy, which made it difficult to transport it over long distances. Because of this, the AN 602 was useless against an enemy whose air defense was sufficiently developed. It is noted that the AN 602 weighed more than 26 tons and reached a length of 8 meters, and the plane carrying it, the Soviet Tu-95, did not have external tanks, so it could not fly from the USSR to the USA. The scientific result of the test was an experimental verification of the principles of calculation and design of thermonuclear charges of a multistage type. It was experimentally proven that there is no fundamental limitation on increasing the power of a thermonuclear charge. However, on October 30, 1949, 3 years before the Mark test, in the supplement to the official report of the General Advisory Committee of the U.S. Atomic Energy Commission, nuclear physicists Enrico Fermi and Isidore Rabi noted that thermonuclear weapons have unlimited destructive power and that the cost of increasing the yield of a munition in fiscal year 1950 prices was 60 cents per kiloton of TNT. In the tested copy of the bomb, to raise the explosion power by another 50 megatons, it was enough to replace the lead sheath with uranium-238, as was supposed to be regular. The replacement of the shell material and the lowering of the explosion power were due to the desire to reduce the amount of radioactive fallout to an acceptable level, and not the desire to reduce the weight of the bomb, as is sometimes believed. The weight of AN 602 did decrease from this, but not significantly. The uranium shell should have weighed approximately 2,800 kilograms, while the lead shell of the same volume, based on the lower density of lead, about 1,700 kilograms. The lightning achieved in this case is slightly more than 1 ton, is hardly noticeable with a total mass of AN 602 of at least 24 tons, even if we take the most modest estimate, and did not affect the state of affairs with its transportation. The explosion was one of the cleanest in the history of atmospheric nuclear tests in terms of unit of power. Fissile materials, plutonium-239 and uranium-235, were used in the first and second stages of the bomb, which in itself provided a large amount of radioactive fallout. However, we can assume that AN 602 was indeed relatively clean. More than 97% of the explosion power was produced by almost no generating radioactive contamination fusion reaction. A distant consequence was increased radioactivity accumulated in the glaciers of Novaya Zemlya. According to the 2015 expedition, due to nuclear tests, the glaciers of Novaya Zemlya are 130 times more radioactive than the background in neighboring areas, including due to tests of the Kuzkina mother. Prospects for practical use. The AN 602 was never a weapon, it was a single product, the design of which made it possible to achieve a yield of 100 Mount Tech. The test of a 50 megaton bomb was also a test of the operability of the product design for 100 megatons. This bomb was intended solely for psychological pressure on the Americans. Specialists began developing combat missiles for high-power warheads, 150 Mount and more, which were reoriented to the launch of spacecraft. UR-500, warhead mass 40 tons, practically implemented as a proton launch vehicle. Ground-X, 8K-82, N1, warhead mass 75-95 tons. Development was reoriented into a carrier for the lunar program. The project was brought to the stage of flight design tests and closed in 1976. Ground-X, 11A-52, R-56, Ground-X, 8K-67. Rumors and hoaxes related to AN 602. The test results of AN 602 became the subject of rumors and hoaxes. Some publications claimed that the yield of the bomb had reached 120 megatons. This was probably due to the overlay of information about the excess of the actual explosion power over the calculated one by about 20%, in fact, by 14 to 17%, on the initial design bomb power, 100 megatons, more precisely, 101.5 megatons. The Pravda newspaper also added fuel to the fire of such rumors, on the pages of which it was officially stated about the AN 602 that it is yesterday's day of atomic weapons. Even more powerful charges have now been created. In fact, the designers considered the possibility of creating more powerful thermonuclear munitions. For example, the warhead of the UR-500 missile with a capacity of 150 megatons, but the latter were not developed further than preliminary designs. There is a rumor about the extremely rapid development of the Tsar Bomba. Allegedly it was completely constructed in 112 days after Khrushchev's order at a meeting on July 10, 1961. In fact, the beginning of development, 1956,